In this video we're going to create actually 3 examples. The first example will not use threading at all. The second example will use threading in order to update the user interface as results come back from our processing. And then the third example will actually use threads in order to execute the processing itself in order to speed it up. Now this application is pretty cool. It actually allows you to input a keyword and it will search in Google for that keyword and bring back the top 10 results. We'll visit each one of those 10 results and look on those web pages for the number of times that our keyword appears on that web page. And this is common functionality if you look at any of the search engine optimization tools that are available on the market today. But it could be expanded to do a lot of cool things, and I'll leave that to you. But for our purposes, we want to look at it purely from a threading perspective. So let's take a look at some of the code as we get started. First of all, the import statements. We import system.net in order to access the internet and to interact with Google and the other websites. The next thing is the system.text, which we are using for the string builder object because we do a lot of string manipulation. And then finally, and most notably for our purposes, is the system.threading namespace, which gives us the ability to create new threads. The next item of note is this public structure website, and I've created a structure because I wanted to keep information about a specific website intact, like its name, its URL, the word count, and whether or not it's been processed, and we'll use that property in the very last example that we'll do. Then we're going to skip the 2 delegate statements, and we'll come back and talk about those when we need to. The next thing is the private member variable, which is an array of those website structures that we talked about just a moment ago. So this allows us to store the 10 websites and all the information that we need about them. And then finally the m_start time, which gives us the ability to do some performance metrics on how long each one of these versions of our application will actually take. So as you see here, we've got 3 passes, I call them. The first pass involves no threading whatsoever, and when somebody actually clicks the first button, which I've called button start, we call the populate websites. The populate websites method is actually responsible for going to Google and getting the results and returning back that private member variable m_websites that's fully populated. Let's go ahead and take a look at that right now. The private sub populate websites, basically we call Google using a get, and at the very end of this line, search string.insert, we concatenate the search terms with this long Google string. And I realized I could use the web service for this, but I didn't want to really get involved in all of that. And the next we have some processing. I've tried to comment it so that you can look through this on your own. I don't want to spend a lot of time, but basically we try to parse through the results that are returned from Google so that we can find both the link's name and its URL within the text. So we loop through a number of times until we find and populate the m_websites array of website structures. So once we've populated that, we want to go through each one of those websites that are returned to us, and we basically connect to them and grab off the information and loop through it to find how many times the keyword actually appears in the search text. And so again, I don't want to spend a lot of time looking at the actual logic for this. That's not the point of our example. We want to display the results and then also calculate how long it took to actually run this. So let's go ahead and save this and run this for the first time. And we'll type in here Fibonacci for you math aficionados, and you can see how the application works. There are things that are going on, however the UI does not update. Notice that I can't even move the window because all of the processing is happening on the UI thread, the only thread for this application. And notice that it took 11.9 seconds. Now, there's some variation in the timing that it actually takes. It depends on how many things are running on your desktop, how fast your computer is, how quick your connection to the website is at this given moment in time, how much traffic there is on the net. So there's a lot of variables, but we're going to get some general sense of how much of a performance benefit we get as we go on through this. But the biggest thing that we don't like about our results is that it took so long for the interface to actually update with information. I couldn't move the window. I couldn't see how far we were in the process. Notice that the progress bar didn't even move at all. This is our little progress bar here, and we didn't get any results from it. And again, this all stems from the fact that we only have one thread, and it was working hard on trying to get each of the individual websites to return and calculate how many keywords were found in each of the websites. So in this example, this website had the word Fibonacci in it 75 times. This had it in 95 times. This one had it 64 times. So we're just displaying just a minimal amount of information here. So let's go ahead and stop this and take a look at the second version of our code, which is actually a single-threaded version, or rather, we're going to add a single thread to this version, and that thread will assist in updating the UI. So we may not encounter any performance benefits, but at least the perception of the user is that something is actually happening. So let's take a look at that. I'm going to go ahead and wind up that region and take a look at our second pass. Let's talk about, first of all, before we dive into that, our public delegate subdelegate UI update. This delegate UI update is used whenever we want to invoke a method on our main thread, our UI thread, from the newly created thread. So we want the threads to communicate to each other, and the only way that we can call a method on one thread from a different thread is by pointing to that method's memory location and calling the invoke statement. So hopefully that'll become a little more obvious when we take a look at the actual code. Let's take a look at the second pass. Parts of it are going to look identical. The first thing that we actually do, however, is that we actually spin off a thread called worker thread. So dim worker thread is thread equal new thread address of worker sub. So worker sub is going to do all of the dirty work. And here we're going to see some similar code to what we saw previously. First of all, we create a new instance of the delegate that we defined earlier and just finished talking about. And I just realized that I forgot a line of code, so let me stick that right here after starting the timer. We still have to call the populate websites method from this worker sub so that we can get the websites into our array, just like we did with the previous version. And then everything else pretty much looks exactly the same. The only difference is that we spun a thread off. Now there is one small difference here, is that I had to use that delegate that I defined earlier in order to invoke the UI update method. So let's take a look at the UI update method right now. And the UI update method's pretty simple. All it does is that it adds the results to the TXT results box as they come in, and it also updates the progress bar. And again, our intent is for this UI update method to run on the UI thread, or the main thread of the application. That's why we had to call this delegate and basically invoke it like we did right here, passing in an array of arguments and then calling the me.invoke method. So let's go ahead and run this example and see the results that we get. Alright, let's use the same word. So we get similar results, and let's go ahead and click Start Thread. Now this time notice that our progress bar is working, and that as results come in, we're seeing them displayed within our UI. Now don't be fooled, the results are actually less this time, but I'm assuming that that's because of network traffic or something else. There really was nothing here that would improve the performance of the application. And again, any variance might be due to something that's completely out of our control. But the neat thing is that it was able to update the interface as we had results, and so there was some feedback to the user. The user knows that something's going on, and the appearance is that the application is operating a lot quicker than it really is. Alright, so let's stop that and let's take a look at our third version. Notice that we've also created a delegate threads UI update delegate, and the purpose of this is to not only update the actual results, which we do with this UI update, but we want to actually print out the time that each of the threads complete their operation. And so we use a different method for that that will function on the main thread of the application. So let's go ahead and close up this second pass and open up the third pass. And the first thing of note is that everything looks exactly the same from our click event from the UI. We clear out the text boxes just like we did in the previous example, and we kick off a worker thread, which I'm calling worker sub multi-threads. So there's a new thread, and it's running this worker sub multi-threads. Now, it does something interesting as well. Notice that after calling the populate websites method, it then creates 3 threads called site processor 1, 2, and 3. It names each of them 1, 2, and 3. We could have named them anything, alphanumeric. And then it starts each of them. Each of the threads are assigned to this worker process next website method. So let's take a look at that. Here's our private sub worker process next website. And essentially what it does is it checks that process property. And here's one of the first challenges that we had whenever we use multi-threads in order to process this array of information, is making sure that each one of them get enough work to do. So every time a thread begins to work on one of the websites by going to that website, pulling down all the information, and start the looping process of looking for the keywords in there, we need to notify the other 2 threads that we're working on this one, don't touch it. And the way that I did that was with a pretty flimsy method, which I hope to improve when we talk about synchronization. But the method that I used was simply this processed property of the structure that we had, and I just set it to true. So if it's false, then go ahead and you current thread, work on this one, flag it as already processed, and then go ahead and continue on with your processing of it. So it's just a way of notifying to the other 2 processes what this process is currently working on and what it's already finished. Again, it has a number of inherent problems, but based on the fact that I've only got 3 threads and we're only doing 10 passes through this, chances are we're not going to have some type of collision. And so the rest of this code looks exactly like the previous examples, where we look through each of the websites and count the words, number of times that the keyword is found, and then we call our UI update method by calling the me.invoke delegate UI update. And then at the very end, we also invoke that other threads UI update method that we talked about earlier in the same manner. Let's take a look at that. All we do here is in the txt threads finished text box, I just print out the thread ID, the elapsed time, and reset the progress bar. And that's in this area right here, so that we can see when each of the threads are finished. So let's go ahead and run this version of the application, and let's notice the speed improvement that we get. Let's go ahead and type Fibonacci, and this time we're going to click the Start Multithreads, and notice that the last thread that finishes, thread number 1, finishes in 4.5 seconds. So It's about half the time of the previous fastest run that we had on our application, just by increasing the number of threads that actually did the work. And notice that also I added next to each one of them, each one of the websites, which was the thread that actually did the processing of it. In this case, the first thread handled this first website, as we probably would expect. And then we see this next thread is number 3, and it found 64 occurrences of the word Fibonacci in this website. I just printed out the title. And then the Fibonacci numbers, again handled by thread number 3. Then Fibonacci numbers and golden section in nature was handled by number 2. It found 95 instances. So it's interesting to see how long it took for each of the threads to actually perform the duties that they took on. So we see a couple in a row here of number 2, then back to number 3, then number 2, then 3, then 2. So in this case, the first thread didn't do a whole lot of work. Maybe it had a hard time actually obtaining the results from the web server, or maybe there was just a lot of text that it had to scroll through. Who knows what the reasons are, but at any rate, we can notice a measurable difference in speed as a result of using this technique. So I hope you have fun combing through this code example on your own and taking a look at some of the techniques that were used in here. And you can begin to see the power of using threads within your application. The danger still exists. I mean, the reason why we didn't run into any problems with this is because there was just so little data and so few threads, but we could definitely run into some instances where we may have some collisions based on the technique that